All right, we'll get started. I want to welcome you all to our first session of Down the SI 5351 Rabbit Hole. And what we're going to do is this is going to be a build series that's going to last quite a few sessions. So we're gonna basically do a weekly Zoom session to go over stuff, and then I'll post hands-on exercises for things like breadboard work, where you build out a circuit and then program the ESP32 to drive it and to play with it and stuff like that. Then we'll also have some in-person build series where we'll actually do some construction of breakout boards, and hopefully by the time we're done, you'll have all the pieces that you can actually take and build a homebrew system, whether it be CW, Whisper, WSJTX, or RIDI and that. So let's switch over, and I'm going to go over the series overview. And this is kind of what what this series is going to cover. So we're going to start out with the goals here. And so the goals of this series is to get you to understand what the SI 5351 chip is and the practical uses for it in homebrew radio projects. Since 2015, actually probably even 2013, this chip, along with one of the 8090-350 chip, which was a digital synthesis chip, have been gaining popularity in ham radio homebrew projects. So this will kind of get you an understanding behind it, also how you can use it if you're into brewing, home brewing radio equipment and projects. It'll also help you understand some of the kits that you can get from places like QRP Labs, the QRP guys. This chip is actually also used in like the KX3, the KX2, several commercial radios. So it'll help you understand some of those. We're going to go through how to calibrate it so you can get the best accuracy as far as frequency in your projects. We're going to go through using the SI 5351 Arduino library and how you can use that to program the chip, not only just for setting a frequency, but how to use it to do phase shift keying and different modes, because you can actually, since frequency shift keying is used for WSJTX and for Whisper and that, you could actually use this chip and programmatically actually have it send the signal that what you would normally be receiving and transmitting using your radio and a sound system, or a sound interface. There'll be an exercise on how to set it up as a VFO. So if you've got some older equipment and you want a new VFO for it, like let's say you find an old Heath kit and the VFO in it's busted, this way you can actually go in and replace it. We're going to build a CW beacon, a Whisper beacon, a RIDI beacon that you can have running. Now you got to remember that when you're doing beacons, you've got to be there, so you can't just let it run, but you can turn it on, be there with it. We're going to also use it as a mixer source for a TALO detector. And we'll actually go through some more advanced programming topics on how to actually get your 90-degree phase shift so that you can actually generate the I and Q signals off of what's being received. And this is kind of the basics of any type of SDR receiver. And then hopefully by the time we get done, you'll actually be able to build a simple CW transceiver and a simple digital modes transceiver, where you can send and receive FT8, FT4, RIDI, but it'll actually be using something a little bit different than sending audio out. You'll actually use, we'll actually set it up to use like UDP to actually do the sending. So the sessions we're going to start out with, additional things we're going to go through. Through the course of this, you're going to learn how to program an embedded processor. We're going to be using the ESP32 by Expressive. It's one of the most powerful microprocessors that has general purpose input output pins, so we can actually drive things, read data. And so you're going to learn how to program that. You're going to learn how to interface to a display, to encoders for input, how to use a real-time clock board to keep accurate time, which is required for things like FT8 and Whisper. Also how you can use a GPS module to also keep time, but also to calculate grid square values. So when you move from place to place with your transmitter, it'll automatically from the GPS figure out where you're at. So when you send your Whisper transmission or your FT8 transmission, it'll include the correct grid square. We're going to go through and talk about low pass filters and band pass filters, and we'll go through steps on how to design and build those. And that'll actually be one of the circuit boards that we'll actually design, print, and build. We'll also go through the basics of amplifiers and build a simple 5-watt amplifier. And then you'll learn how to design a circuit board and get it manufactured at a PC fab house. And then you'll also get some practical experience on how to solder through hole technology as well as surface mount. So there's a lot of things we're going to be covering. And this series is kind of really long in that case. Session 1, we're going to basically go over an introduction, talk about the materials and software that we're going to use, and then just a high-level overview of what the SI5351 is. And then we'll go in Session 2, we'll talk about actually interfacing the ESP32 with the chip, calibrating the chip, how to interface with an OLED display, how to interface with an encoder for input. In Session 3, we're going to start talking about basic transmitter overview. What makes a transmitter? What do you need to have in order to transmit a signal? And we're going to have a practical exercise where you'll set up the SI5351 as a variable frequency oscillator. And this is going to be kind of the core of what we use the 5351 for, how to make it switch bands, how to use the encoder to dial in your frequency that you're going to use, and those type of things. In Session 4, we're going to talk about RF filters and why we need them and how we are going to design them. We're going to go through some of the design practices best tips based off of years of experience from the QRP community and the amateur radio community, so that we'll have a simple sheet that you can go through and say, if I want to build something for 40 meters, here's the components I need, and make it much easier for you so you don't have to try to figure it all out in your head or with a calculator. And then we're going to actually do an actual schematic design and PC board design to create a breakout board that you can actually build out an RF filter. And this way it'll be a basic board based off of the design that we come up with, that you can create anything from 160 meters down to 6 meters. And then we'll go through sending that design to a PCB manufacturer and walk through the process. In Session 5, we're going to hopefully we'll have back our boards in that, and this will probably be our first in-person build, and we'll populate some of the filter boards, and we'll go through the basics of through-hole and SMD and SMT soldering, and so everybody can get a chance to build out a board. Most of the stuff we're going to be doing is going to be SMD based and surface mount based. So it's going to be a little bit harder. There are going to be some through-hole components, but the majority of stuff is going to be surface mount. So we're going to show you 3 different techniques on how to solder surface mount, how to do it with an iron, how to use it, how to do an electronic hot plate, and then hopefully we'll also show how to use a reflow oven to do it. In section 6, we're going to get started with building out once we've got our filter, we're going to start looking at building a CW beacon using the 53, 51, and the parts that we built. And then in section 7, which is coming up, we're going to look at how we can interface with a real-time clock and a GPS with the controller, because we're going to actually need that information and that interface set up before we can actually get into building out a Whisper beacon, which we'll do in session 8. And in session 9, we'll look at doing a RIDI beacon using this. So we'll basically cover all the different types of digital transmit from there. And then in session 10, we're going to look at boosting our signal, because as it is, we'll probably just be in milliwatts. So we're going to want to, amplify our signal so everybody can hear us around the world. So we're going to start talking about amplifiers, and we're going to walk through a very simple 5-watt amplifier breakout board design, and that'll be another board that we send off, and will become an in-person build day. We'll be building out the amplifier, testing it, and everything. And then session 11, we're going to start talking about the basics of receivers. And we're going to talk about the TALO detector, which is is a very simple, straightforward mixer that you can make. And the nice thing is whether you're using CW, sideband, or FT8, that TALO detector can actually be used across to all three, so you don't have to build all this special stuff to to handle the different signals that we're receiving. And then we're going to actually design a breakout board that will be used for the TALO detector, and that'll be another one we send off and do another build day on. And then 12, we're going to talk about an audio amplifier and design it so that you'll be able to hear what you're receiving. And then we'll also look at some CW keyer circuit, so that you don't get a bunch of sharp noise when you're actually sending or keying a CW transmitter. So this will actually make your keying a lot easier to understand. It won't be really sharp and sound kind of really bad over the air. I don't know how many people have actually ever listened to somebody that's using like a Pixie or a Michigan Mighty Mite or some of the older kits, some of the tuna kits, but they have some spikes whenever they click in, and you get bounce and that from the keyer. But we're also going to use ESP32 to generate an iambic keyer as part of that. So it'll be another thing that you'll do some programming and build out a circuit and then play with it and put it on the air. And then in session 13, we're going to look at building a full-blown CW transceiver. And then finally, in session 17, we're going to look at building out a full digital mode SDR transceiver. So that pretty much covers what the sessions are. So hopefully over 14 weeks, plus or minus, and a couple in-person build sessions, you'll have a basic toolkit for building at-home radio projects.